Hi everyone, good afternoon. Yes, I'm Penny from National Grid, and today I will be talking about affordability analysis using PLEXOS. So let's start with a bit of introduction to the company and what National Grid is. So we are a transatlantic business delivering energy to our customers safely, and by doing this, we are playing our part in developing an affordable and reliable clean energy system. Our strategic focus is on energy networks. We own the transmission network in the UK. We own the transmission network in England and Wales, and the largest distribution network serving millions of customers in South Wales, South West, and Midlands. We have National Grid Ventures, which operates in UK, Europe, and the US, and is the interconnector business, and then National Grid Partners, which is the venture arm of the company investing in innovative startups. In the UK, we're going through the largest overhaul of the electricity grid in generations. We have doubled the investment compared to the previous 5-year period. And with doing so, we are aiming for like a future-proof network where we can connect new types of generation, like offshore wind, but also dealing with the kind of increasing electrification of transport, heat, and AI. And doing so, we will kind of rely less in gas markets. With that as well, we will kind of enable customers to have more affordable power by reducing billions in constrained costs, whereby today customers pay for generation that has to switch off because it can't flow through our network due to congestion. In terms of the distribution business, the current price control from Ofgem ED3 is of pivotal and great importance. Engage sees this as a time for bold investment and transformation, where we can enable a smarter and more flexible system and bring regional benefits to our customers. Now, the energy transition has fundamentally shifted in the last few years, not so much in ambition, but in priority. The UK households are facing lots of cost of living pressure, which is kind of keep on building up. We see that the UK has one of the highest retail prices among the developed economies. And if we look at how the customer bills have evolved over the past few years in the UK, we see that we're constantly on a kind of high prices. And the recent price cap from Ofgem as well is expected to increase customer bills by 13%, which is one of the kind of highest increases in the last 2 years. So today the question is not about how we decarbonize, it's more how we do so by keeping the lights on, but also ensure affordable power. And we see this playing out in real time with geopolitical shocks, supply chain pressures, and the growing demand because of AI and electrification, which is basically shifting the conversation that like regulators, markets, and transmission companies have more around affordability and reliability. And this moves at the forefront of the policy agenda. So within that context of how do we decarbonize while also having an affordable and reliable system, what I'm going to do today is talk about some of the studies we have done internally in National Grid to support our network investment kind of analysis. So the focus of today is going to be how we use PLEXOS and focusing on the components we've used PLEXOS for our scenarios and sensitivities. And we will look at the whole system impact and what this means for an average consumer, rather than going too much into different customer archetypes and people adopting different low-carbon technologies. And we will also not focus too much on the network planning in that much detail, I guess. So to start with, let's look how our kind of modeling sheet looks like and the different tools we have developed. So we have a wholesale market model where we cover GB and Europe in quite great level of detail in terms of the different generators and demand kind of assumptions in that system. We build this at the national level, where we try to have different scenarios where we look at supply and demand and ensure that we meet resource adequacy. The next layer we have is a network zonal model, where, again, focusing on the UK market, we've split the UK into different zones where we apply boundary capabilities and different kind of transmission limits. And then on that, we are building a redispatch balancing model where we're trying to replicate the balancing mechanism and trying to understand the constraint costs and calculate the thermal constraint costs. So this is kind of the core of our modeling tools and where PLEXOS comes in play. And we develop this across different base case and scenarios so that we can assess a range of potential outcomes. We do have analysis around specific kind of different archetypes and customer profiles, but we will not go too much into that today. So the next thing we've developed is a whole energy customer bill calculation, which is really based on the Ofgem methodology. And it consists of different components in terms of wholesale costs, network costs, policies, and other kind of retail aspects. And again, the focus today will be really on the areas where we are using PLEXOS to do those calculations. So we derive direct fuel, electricity fuel costs, which is coming from our day-ahead price forecasting using PLEXOS. We also have a capacity market, capacity auction prices being forecasted, where we take into account the profits of plants and kind of what this means for potential clearing price in the capacity market. And then we also calculate the CFD component, which is understanding what is the additional payments that go to renewable generators under the CFD scheme, comparing strike prices and day-ahead prices. On the network cost element, again, the focus of today will be really on the balancing use of system costs, where we embed the constraint cost forecast that we get from our redispatch model in PLEXOS. And then the rest of the components are also get calculated, but perhaps that's not the focus of today. So before going into more specific case studies and examples, one more thing I guess worth mentioning is consumer-led flexibility, and we've heard about this in the previous panel mentioned as well. So we expect the electricity demand to grow, and with that, peak demand will grow by more than 25 gigs in 2050. So we're talking about big increases in demand. This is coming from increased electrification of heat and transport and AI loads and data center demand. Not all demand is equal in the sense that different elements of demand will have different contributions to peak, and different aspects of that demand can also be more flexible and shift around cheaper prices or higher renewable generation periods. So what we've developed in our model is a way to capture this consumer flexibility or like flexible demand, and for that we use the purchaser class in PLEXOS. So we defined max energy day, which is max and minimum energy day, which is how much basically demand has to be served within the day. But also the max load, which is like the maximum megawatts that we can shift at any period. And then with that, we can see how demand shifts from higher priced periods to lower priced periods, and overall the effect is a more flattening shape both for demand and price. The parameters that we kind of input in the model are based on our kind of forecast of EV and heat pump uptake, and what we think the percentage of this fleet being flexible. And to do that, we use a range of different inputs, like the EV charger capacity, heat pump size, the number of heating hours and thermal storage available, as well as uptake in terms of like smart meters and technology readiness, as well as the kind of customer engagement and how much consumers we think will be more engaged in that concept. So kind of taking all these components into account, we can then define the properties that go straight into the purchaser class in PLEXOS. So to see this more like in practice and what it means, we start from like our baseline case here, and we present a high electrification, high flexibility sensitivity. So what is worth kind of highlighting and starting from is under the baseline case, look at how the average hourly power prices are set to evolve from today, 27 out to 2035, and we've looked at the different kind of seasonality. So we see that during spring and autumn, we have the largest share between like peak of peak prices. It's in this example 54 euros per megawatt hour. Moving forward to 2035, because of like inherently the assumptions we're making under this baseline scenario, there is some flexibility enabled. We see that this kind of minimum maximum price level reduces to 35 euros per megawatt hour. But then when we're actually looking at the sensitivity where we enable 3 times the flexibility at peak, then this gap reduces even further. So overall, we see that the wholesale price can reduce significantly. We can have a reduction in peak demand gigawatts, reduction in constraint costs as well, because we can manage to shift the demand away from like the more congested and peak times, or like enable demand when we have more renewable generation. But then on the other hand, this means that technologies like wind or solar see lower capture prices, and this kind of has an impact on those technology economics. The other important aspect as well is the location. So thinking about the kind of zonal concept of the GB market model that we have developed, where we actually place this additional solar capacity, battery capacity, or collocating the two technologies together can lead to different results, and there could be locations where you could also see higher benefits in terms of savings for constraint costs, for example. So this is quite important, I guess, aspect of what also distribution grids can do, and why with the kind of increased electrification of technologies like EVs, heat pumps, we can see that the distribution grids can have a central role to play. So on that note, we've seen that the DSO flexibility market is on the rise, and specifically the NGED teams have gone through a lot of kind of work to increase the growth in the flexibility market. So 2025 has been a record year in terms of like how many registrations and growth we've seen in the market. This is due to kind of better data sharing and more standardizing of the process in terms of registrations in the market gateway, but also creating more products and adding more value to both the participants and customers. We've seen increased registrations from domestic technologies like electric vehicle charging points and batteries. And then the other kind of important milestone worth mentioning is that 2026 so far has been a year where all the kind of activation events have been met by low carbon technologies, so like EV charging points, batteries, and kind of renewables in general. So I guess the first case study I would like to kind of present in terms of how why this matters for us and why we're doing this. So as part of the RIO framework and the ED2 kind of framework, the DSOs have to fill in this performance panel report to Ofgem, which is basically an assessment for how much distribution networks are enabling this kind of more flexible and smarter system, and is linked directly to the incentive rewards that they're getting. So we've supported the team there with whole system analysis, where we've done some cost-benefit case studies using the Green Book methodology, accounting for the benefits essentially of bringing this additional flexibility to the system. And within that, we can capture also impacts in terms of CO2 emissions. What I'm presenting here is more on the kind of customer bill aspect of things. So if we think of these flexibility markets, what we've assessed is for all the different types of technologies that have registered to the markets, kind of assess a generic additional capacity and what this means in terms of the interactions between wholesale prices, CFD payments, constraint costs, to understand how much value this is adding to the system, and then actually model the whole kind of technologies that have been registered on the flexibility market the past year. So this really shows basically the benefit that we can have from enabling those flexible technologies and actually be able to bring benefits to the customers. And then the other kind of key study at the moment is around the next price control period for the distribution networks, ED3. For that, Ofgem basically has raised the bar in terms of consumer engagement, and the incentives are not just linked to kind of ambitious plans and kind of business planning, but it's really linked into actual kind of delivery of those plans. We've also moved from this flex-first approach to just leaving to the discretion of the DNOs and DSOs how flexibility is going to be used. But ultimately, the question comes down to what will ED3 cost for the customers and what are the different kind of options there. So it is really important to kind of understand what the different scenarios mean. And we have the niche scenarios, we have the transitional regional energy plans, all seeing a step change and steep increase in demand from heat pumps and EVs. We're trying to understand how can we kind of, I guess, what is the trajectory we're on at the moment? What does it mean in terms of like total cost of ownership and customers uptake these low carbon technologies? What are the available policy schemes like the Warm Homes Plan or Boiler Upgrade Scheme in the UK to kind of enable the heat pump uptake? So we're coming up with different views in this kind of demand trajectory. And I guess assessing all those different scenarios or sensitivities, we can understand how we can see the kind of customer impact and cost for consumers changing from an external scenario to our kind of internal alternative scenarios. And this is where kind of the flexibility aspect becomes really important, because we could be using flexibility initially to flatten, and flexibility markets to flatten that demand curve, while we can bring in the network investment when we will have more certainty around how the demand growth is going to look like, or at more kind of critical times, and kind of, basically have a balance of the two, and in the end, kind of for the benefit of customers. And then it's not only sensitivities, I guess, around the different kind of demand level and how fast we move towards a like net zero world, but it's also thinking about the external environment and the volatility in gas markets or weather volatility. So we're also doing quite a lot of sensitivities in that aspect, trying to understand this kind of uncertainty. Because both gas price and wind volatility can have a strong effect on the markets and affordability. So again, under kind of a view where we are still moving towards and pushing towards CP30, we see renewables dominating the system and gas setting the price less often, but still there is some reliance and some link with the gas markets. So our outlook and our baseline suggests that by 2030 we would have 50% of the time gas setting the price compared to 70% today. But if we were to look at gas price shock or extreme high gas prices because of, for example, geopolitical tensions and events similar to what we've seen in the past, this could have an impact on increasing wholesale prices, constrained costs, as well as seeing higher capture prices for technologies like renewables, for example. So we're trying to understand what is then the trade-offs between the different components of what goes to the customer bill in terms of wholesale costs, CFD payments, constrained costs, and see how much the impact is under all these different kind of cases. So clearly high gas prices has a deteriorating effect on customer bills. Wind as well is another kind of important factor, either because of supply chain and financing issues where you don't see the wind build-out coming as fast in the system, or more like weather events where you can have fluctuating generation because of extreme weather events. So again, it's quite interesting to see how a high wind or low wind case and at different time frames, 2030 can be very different to 2035, what is the impact on consumers. And I guess highlight from this analysis here is that while being worse off with higher gas prices and kind of higher wind, when you combine the two together, actually the increase for customer bills is much lower. So essentially, to conclude, I guess affordability is a key pressure, and we're taking this into account into our modeling, and this is how we're using PLEXOS to understand different combinations of flexible demand generation, network capability, how all this interact, and what it means for kind of the combination of the variables that matter for customer and customer costs. So we can see and we can have quantified impacts in terms of like the wholesale prices, the CFD payments, the constraint cost trade-offs. And this is where the whole system approach is really important, to be able to understand how all these different components interact rather than taking them into account individually. Flexibility and network investments are key enablers for this smarter and more flexible system. And this is where we see the policy discussions shifting to. And it's also important to capture those into our modeling, since we are seeing now that the traditional kind of flow of information from the transmission to the distribution network to the customer is actually becoming more dynamic and bidirectional. But it's important to be able to capture the right physics of the distribution grid as well, so that we can capture the kind of right value of flexibility. And customer archetypes are evolving, and this is quite critical as well. So when we're thinking about how we're capturing demand into our modeling, and this kind of flexibility aspect is something we're keep researching and trying to kind of find the best ways to include into our analysis. So yeah, thank you. Happy to take any questions, if there are any.
We've probably just got time for one, if that's okay. Thank you.
Thank you so much. I was wondering, given sort of the importance of some of the ancillary services market, CRMs and stuff in these kind of calculations, can you speak to the accuracy with which you manage to do that as part of these calculations, and the way you do that in your established sort of PLEXOS process and modeling suite?
Mm-hmm. Yeah, so I guess we're not necessarily capturing all ancillary services, so it's really the balancing, so constraint cost from the balancing component. And we're also doing this for kind of just England and Wales, or we have to kind of extrapolate information for the whole of the GB because of some other components of our calculations, I guess, and where we have good information. So I suppose when it comes to the price forecasting and the kind of constraint costs, we're always benchmarking with external scenarios and trying to understand if we're different, why, and yeah, have that benchmark. Also compared to like forward prices, and kind of we're doing a backcast exercise quite often as well, just so that we understand that we're not missing something fundamental in our kind of basic modeling from PLEXOS. But then, of course, there is room for deviations, and this is where kind of the sensitivities and scenarios become handy to be able to capture that range and at least understand the direction of travel, because we know that we will not be 100% or like accurate. Thank you.